All right, hello everybody. Welcome to the Semantic Kernel Public Community Office Hours. As always, it's a public forum, so you're all welcome to raise your hand to add comments, questions, or feedback in the chat. We can always get to those when we have time. But yeah, we have a very packed agenda, and we have many things to go over, a lot of cool demos to show off, and a lot of good questions that have come in from the community. So yeah, let's just get right into it. Okay, so first announcement is, so we talked about this last office hour, and in preparation for the 1.0 release that's coming very soon, we want to promote, and get feedback on the 1.0 SDK, and we're going to be hosting a week-long hackathon that's available worldwide. So wherever you are, you can participate, you can join in. So actually, let's just do a quick look at that. I'll put this in the chat. Yeah, basically, it's pretty freeform. Honestly, like if you want to hack on whatever your favorite language, it is true that 1.0 is more mature or more well-defined in the .NET version of Semantic Kernel. There's some like other examples inside if you go to the proposal, actually, right, the V1 proposal, you can see that there's at least maybe a couple examples in Python as well. But I would say, treat this as a time, right? Whether you're C#, Python, or Java, treat this as an opportunity to just play, build something with Semantic Kernel that you'd be happy to show off, and yeah, we'd love to see it. And in particular, of course, if you're going to be using the 1.0 beta, which the newest version will drop on Monday. Yeah, definitely use that so we can incorporate all that feedback into the latest release. So yes, join the hackathon, and yeah, look forward to seeing what you guys build. Okay, next announcement is we have, for the Python people in this community, right, we have the latest version of the Python SDK for Semantic Kernel. It's a breaking release, and it's mostly because we have incorporated the OpenAI 1.0 SDK into SK. So yeah, definitely if you are already using Python, right, upgrade to the latest version, especially if you're using the latest OpenAI packages. So yeah, this is a big push, big change, and more to come. And actually, since we're here, I want to introduce everyone in the community to Evan, Evan Matson. He just joined the Python, or he just joined the Semantic Kernel team full time to work on Python. So yeah, welcome Evan to the community.
Thank you very much.
All right, and for Java and C#, Java I think is still pinned to the previous version. So if you go to the GitHub releases, you'll see whatever the latest Java version is. And C#, as mentioned, the latest release candidate will drop on Monday. So stay tuned for that blog post that will come out then. Okay, in terms of new videos that are out there right now on YouTube, so in the APAC office hours, the Asia Pacific one, my colleague Vic actually gave a walkthrough of a Copilot reference architecture. So if you're interested in that, to see like, okay, how could you stitch together a bunch of different Microsoft services and all that with Semantic Kernel, you could see that and refer to that. All right. So those are all the announcements, and I think we have a lot of great things to show off next. So first off is Teresa. Teresa is going to be showing off a demo of the new Handlebars planner that's going to be coming soon with the 1.0 SDK. So Teresa, I'll hand off to you.
Hey, so I'm Teresa for those of you who haven't met me yet. So in the past couple of weeks, we've been testing different planners in different programming languages to one, replace the current sequential planner and the stepwise planner that we have. We were just testing them and they weren't as reliable as we wanted them to be. So we've been testing them in different programming languages such as Python, C#, JavaScript, and Handlebars. Today, I'll be demoing the Handlebars one because our philosophy going into this for the ideal planner language was we wanted it to, one, be well known and understood by the model. And then on a similar vein, we also wanted a language that had constrained functionality and syntax to minimize like the chance of the model hallucinating functions, whether the functions are irrelevant or incorrect. And also the language we wanted it to be expressive, enough to represent complex plans and workflows, as many of you guys have requested, to accommodate like a wide variety of requirements and scenarios for our users. And ultimately, we landed on Handlebars for the ease and the security of the templating language. We have full control over the functions that are executed at the time of the template render, rather than like for Python or for JavaScript, having a block of code to be executed as the plan, which just came with a multitude of security concerns. So I'll demo this, but because we control the Handlebars instance, we explicitly define all the functions as handlebar helpers in order to enable any operations before we execute them. And let me share my screen. Can you guys see my screen?
Yes.
Okay. And I can't really see Teams right now, so if you guys have any questions or comments, just go ahead and unmute and chime in. But this Handlebars planner is actually already available in the Semantic Kernel repository today if you guys want to pull it and play around with it. But we're still iterating on it and trying to finalize it before V1. But it's all under the planners.handlebars folder under planners in the .NET folder. And it starts here with.
Did we lose Teresa? If she's not back, we do have other demos we could go to. Okay, so for context, while Teresa hopefully comes back in, Chris is going to be demoing OpenAI assistants and kind of just the latest work that himself and Gil have been doing here. So go ahead, Chris. And if you can zoom in a lot, that'd be good.
Sure. So this is the .NET version of some experimental work we had done with assistants. So at a high level, the assistance project is checked in under, this is the .NET version. Evan's working on Python version, I'll let the cat out of the bag there. And it's under experimental assistance. And also there's some kernel syntax examples too, 70 and 71. 70 actually shows kind of 4 different variations, and 71 shows multiple assistants interacting. We'll pivot to those examples, but I put together a very simple example just to run to show the basics. So there's sort of 2 flavors. One, which you're seeing here, is just exposing the assistant pattern kind of as defined by OpenAI. Internally, it is using a kernel to do some chat completion, but primarily it's just interacting with the REST endpoints. We're passing in the model name. In this case, it's 2.5 Turbo 1106, so the assistant enabled one, and the API key, and the system instruction for the assistant, talk like a parrot, and the name, which is optional, and description, which is optional. So once we have the assistant, create a thread, add user message. This is just basically go through a chat loop. So if you're reading the OpenAI specs and you look at this, you're going to see like a very direct alignment. And if we just run it, you'll see pretty much exactly what you expect. And so I set this up as a separate console project for the demo today, instead of just running the kernel syntax examples, just to verify, to walk a different path and just re-verify that the NuGets are working, that everybody in the audience today can download the NuGet and do exactly this. So here it's outputting the assistant ID, which persists the input message, the assistant message repeated like a pirate, the parrot sound. Same thing here with the message IDs. If you were to go back, these message IDs are persisted on the OpenAI backend, so they can be retrieved. So this is pretty much the no-frills assistant experience with no functions or tools. You can see we're just importing Semantic Kernel and the assistance package. In terms of, we look at some more advanced, interesting cases in the demo. So while that's just the basic pattern, one kind of spin that we put on the assistant is the way we've implemented, it's actually a function. So once you have an assistant, it can be imported as a plugin to have functions, and then you can just call it as, so this is like the first SK kernel function. So here's the assistant exposed as the iAssistant interface, but it can also be imported into the kernel plugin / function ecosystem and then interact with any other function. At that point, it's just another function that's being called and getting the result, which leads to the next example, because just to give it, so here's this is the pirate one. You can also initialize this assistant with functions plugins, and it can do function calling. Those are demoed here, and that kind of all comes together where here, the kernel example 71, we're initializing 3 assistants. One uses a tool to retrieve some menu information, just some static information. And this is the definition for the tool. So as an option, you can define your assistant in YAML and import it. In this initial example, I kind of showed the direct pro code version. The importing the YAML just calls into the builder, but that's what we're doing in the demo here. So basically, this assistant is just basically said, oh, take the input, and if you can run a tool to solve this objective, do it. And the tool this one got was the menu information. And then the parrot assistant we just saw. Both of these assistants are imported as functions and passed as tools to kind of a manager assistant. And so the manager will take an input objective and then determine which function to call, which function is most appropriate to call. In this case, the functions are actually other assistants. So for this objective,
Chris, can you increase the font again?
Oh, yep. So so basically, the tool assistant is just triaging which function to call, and the function is in fact just another assistant. So for this objective, it would call the menu assistant. For this objective, it would call the parrot assistant, and then for the others, it just no assistant, and it just responds in chat. The kernel examples are available for everybody to run. I don't have it configured right now to run, but those are available. 70 shows the basic flavors of doing the chat loop, kind of the assistant-based chat loop, and then also treating the assistant as a function, which using the assistant as a function, I think, is really going to be compelling in terms of creating capabilities in the semantic kernel ecosystem, and interacting with other native and semantic functions.
Chris, a question that came in the chat is, in this case, is the tool assistant acting like a planner?
You know, it's not a planner. This might be a little controversial, I suppose, but we were just talking about this yesterday, actually. And I mean, there's certainly significant overlap in the OpenAI function calling pattern and what planners do. I think in Teresa's presentation, she makes a compelling argument to distinguish, where a planner is able to call hosted OpenAI functions and also local native functions. So in that way, if you have a lot of native functions or plugins that you're interested in using, a planner could be more capable potentially than the OpenAI one, depending how and then also the assistant experience, the OpenAI function calling assistance, is a little more like the stepwise planner, sort of. And if you want more of a comprehensive end-to-end plan that you can expect and audit and re-execute, I think the planners might have the advantage there. If Teresa's back on, she can.
Cool. And last question is, how does the manager know which function to invoke?
Oh, great. Oh, well, that's the same way that, I mean, if you just did like a normal chat completion prompt separate from assistant with OpenAI function calling, the logic is exactly the same. In fact, the documentation for assistant function calling, I'll link it in chat after I'm done. Just links to the comment. There's no distinction between just regular function calling and assistant function calling. They're the same underlying mechanism. So effectively, based on the descriptions and the semantic understanding of the metadata that's presented, in particular, there's the OpenAPI manifest is provided, which describes the functions and parameters and return types, and then the model reasons over that.
Awesome. Well, thank you, Chris, for this walkthrough. And as mentioned, all these examples are in the kernel syntax examples, or it's on the links that Chris provided. So thank you. All right, we will transition back to Teresa if she's if her connection is good.
Hey, sorry guys. I was just talking and I did not realize you guys could hear me. When did I cut off?
I think just restart again.
From okay.
But
so,
without the preamble, we have the preamble.
Okay, so I will go ahead and share my screen. I think that's probably where I cut off last time. Let's see. Okay, can you guys see this? Yes, okay. So for the Handlebars planner, we chose the Handlebars planner because we have complete control over like the functions that can be executed in the plan, as compared to like one of the actual programming languages like Python or JavaScript, where we would get a block of code back and we would kind of have to execute that code as the plan. So that came with a multitude of security concerns. With the Handlebars instance, we have to explicitly register each function that we want to expose to the Handlebars instance as a helper. And that's how we get to control all the operations that the Handlebars planner is able to run. For like the Handlebars, so in Semantic Kernel today, we already have support for Handlebars templates for your semantic functions. So you can, that's in a completely different folder. So that's under like the template engine Handlebars. So if you have a Handlebars template, you can run that as a semantic function, or just a function or plugin. But for the Handlebars planner, we had these extensions because we wanted to bake in some custom functionalities, like common operations that the planner tended to hallucinate. For instance, like concatenation or different comparison utility functions. So this will hopefully be integrated with the broader template engine in the coming week. That's what I'm currently working on right now, but you'll be able to find that under the Handlebars planner today. So the Handlebars planner has 3 different kind of helpers for exposed to it in the Handlebars instance today. So you have all the functions that are available in the kernel. You have the system helpers, the ones that I just mentioned that we bake in, the custom ones. And then you have the built-in Handlebars helpers, such as like each and conditional. So that enables loops and conditionals in the planner, which we didn't have in the sequential planner before. So you can see like the render process for it here in this file, the Handlebars template engine extension, and then the Handlebars planner file is where you actually get to see the plan creation process. So it all starts here with the create plan async, and I've split everything like into all of these like private methods right here, all kind of feed into this create plan method, this higher one, and I tried to split it so it became more manageable, so you guys can see how the available functions manual is built. And then the Handlebars template is this semantic function that we execute. I'll go through that in detail in just a second. And then we also support complex types now. So that's like a pretty big change coming with V1 is we have complex type definitions for all of the parameters, inputs or outputs. So this is really helpful, especially with like the OpenAI plugins that you import, so then you can have complex payloads, and the planner is able to identify the structure of these a lot better now, and actually like pass in an object that makes sense to the function it's trying to invoke. And so that's the planner, and then it outputs this kind of Handlebars plan right here, and this Handlebars plan is just a custom class where the template itself is the Handlebars template is what represents the plan. I'll show examples of that whenever we run the samples. And then you also get to see the prompt that was used to create that plan. And then this kernel instance is what's used to actually invoke the plan. So whenever you have a plan, you can just have the plan and then run invoke on it. And then it essentially what happens is it renders the template and it invokes all those functions as specified by the plan. So we can pivot over to the prompts because this is where like the bulk of the magic happens. Right now, we kind of have 2 versions of the prompt, and I've split them up because currently the Handlebars planner is already in the Semantic Kernel repository if you guys want to take a look at it and play around with it. But the prompt has both versions of this prompt that I'm about to show you. So I split it up just for ease of the demo, but there's one version that allows loops and then the other version doesn't allow loops. So what I found with testing is if you're testing with GPT-3.5 Turbo, it is able to handle loops, but it just doesn't handle loops as well as GPT-4. So I configured like the kernel syntax example to automatically switch between these 2 templates, just so you can kind of get a visual of like the limitations of the different models. But this one right here is the one with the loops enabled. So the planner itself does really well with like scheduling the loops and then putting the logic within each of the loops. So we first start off here with an example just of how it is able to like syntactically structure the plan and how it can call functions, just give it a firsthand example. And then here we define all of the different helpers that it's able to use. So we start off with the baked in Handlebars helpers. So these helpers are just part of the Handlebars syntax right off the bat. So if, unless, each, those are the conditions and the loops I'm talking about. And then we bake in our own custom helpers down here to help it use the loops and the conditionals, and also just for like other common utility functions that it tended to hallucinate, such as like comparison. And then these right here, set and get, are 2 of probably the most important helpers that we bake in because it keeps the structure to like variables really well and just data handling. And then JSON concatenation, also 2 big utility functions that it tended to hallucinate. And JSON itself just stringifies whatever the object is. So then you kind of get this readable object out. And then this is where we put in the support for the complex type definitions. We essentially print out the schema So then it knows. And then down here, we loop through all the functions that are available in the kernel and print out the description and the parameters and then the output. And then these are just some of the like tips and tricks that we give it in order for it to actually structure the plan. And this Handlebars planners is like very reliable as compared to like the old sequential planner that we had. And it's able to complete the goal pretty easily. And then over here is like the no loop one. So you can see like it's basically omitting the each helper that's baked into Handlebars. So we just don't have any examples of it. And then we don't include it here in the out of the box helpers, but essentially everything else is pretty much the same. And I'll put links to this in the chat so you guys can follow this a little easier. But in the kernel syntax examples, we have this example 65 for the Handlebars planner. And there's a ton of different samples in here where you just kind of have one where a plan's not possible, like you don't have enough functions in the kernel to fulfill the goal, and then some basic examples, and then examples with complex types. And then these samples get more complex as you run them. So you can see like a demonstration of how to use the planner here, where you import whatever functions you want first into the kernel. That's the basic setup. But in order to actually use the planner, you instantiate a planner. And then you create the plan. And then if you want to inspect the plan, you can go ahead and print it out. And then you could invoke the plan. And this is already configured to like print out everything for you. So if you just want to run this example, you would just go to the program file under kernel syntax examples, set up all of your Azure OpenAI or OpenAI keys, and then change the filter to either Handlebars or 65 or whatever example that you want to use. And you can just either run it from the terminal using .NET Run, or if you're in VS Code, you can run it from the run and debug like file over here. So hopefully this will be kind of fast. If not, I already ran it over here so you guys could see it. But let's see.
While we're waiting for this, Teresa, could you maybe share anecdotally, like how better is it? Maybe some metrics or things compared to previous planners?
Yeah, so I don't have like quantitative metrics for the previous planners. They were just able, when we built some integration tests that we were running, and the more like plugins and functions that we fed into the kernel as available functions, it like started to fail like kind of almost immediately, like in pretty low numbers of plugins. So that's why we decided to like start rebuilding the kernel or the planners. And this one, like it's with GPT-3.5 Turbo. Like I mentioned before, it doesn't handle loops as well, but it was still like pretty like 75% like reliable when I was running just this example. And like right here, this first example, it should explicitly say that more helpers would be required if there's not enough available functions. With GPT-4, it passes like over 90% of the time as expected, it has the expected behavior. With loops or without loops. Without loops, it is like almost like always passing as expected. So let me go over these examples really quick so I already showed you guys this first one. The second one just gives it some dictionary plugins, and then it's able to like get the plan. You can see the plan itself is a Handlebars template. It should guide you in the different steps that it's planning with comments. And then you can see here the data management is a lot better because we expose this set and get helpers in order for it to explicitly define the data that it's passing around. And then this is the result. It's able to like format the result better because of these baked in helpers. Here it's trying to write a poem and then translate it. We put in multiple plugins and it's able to like bring it down to the writer plugin. And then this one is we're trying to get it to write a chapter book. This kind of takes a little while. I don't know if it's gonna like how fast it really is gonna be. So we're just gonna pivot over to this other tab where I already ran it. So you can see that it's able to use the loop, and then for each of the chapters, it can write out the chapter, and then it prints out the book content. So it just concatenates each chapter into the book content and then prints it out. So you can see chapter 1 here, chapter 2, I don't know where chapter 2 is. Yeah, chapter 2, and then chapter 3 should be down here somewhere. Yeah, chapter 3. And so it's able to like plan out all of that. And then for this last example, I print out the plan so you guys can kind of see like what the actual prompt looks like whenever we pass it to the planner in order for it to create a plan. So you have this example right here. And then all of like the different baked in helpers. What I wanted to show here was how the complex types are dynamically printed to the prompt before you pass it. So this dictionary entry is a complex type that has the word and the definition properties. And then down here, like whenever it's specifying like what's going to output, it knows exactly like what this function is going to output or what this function expects to get in. So this is super helpful with like complex payloads whenever you're working with various plugins. And it can pass in those complex payloads or complex objects between different function calls by first assigning it to a variable and then just passing it as the input to the next one. And so that's it. I'm sorry that was fast. I know I talk really fast, but you guys can ping me offline and I can help answer any questions. Yeah, and then you can run these examples by yourself. Like Chris mentioned, all the kernel syntax examples can be run from program.cs.
Awesome. This is really good. Thank you, Teresa. I'm glad your connection got fixed. But yes, as she mentioned, right, there's lots of examples, lots of great content that's already there, but also will be circulated, especially as we finalize 1.0. And again, another plug to, if you want to hack, let me share my screen again. If you want to hack with us, right, make sure to join the hackathon happening on the 4th, from the 4th to 11th. Okay, so continuing the updates, I'm going to pass it off to Devis to give some updates on kernel memory, which there's been quite a few since the last time Devis shared.
Hello, everybody. Hi, thank you for sharing. Give me some time. I try to be fast. There is a lot of content, but also a lot of questions in the next slides. So for people that don't know, the kernel memory is basically the new implementation of the memory pattern that we're moving from Semantic Kernel into its own solution. It has its own repo, and there has been a lot of work in the last month to reach the first milestone, which is basically having a plugin that you can use to replace the old plugin in Semantic Kernel. So the first thing that we did since the what is this window? Okay, since the last update, we have been revisiting the structure of the repo a little bit. So now the repo is structured in two main areas: the clients and the service. So the idea here is that you should run the memory as a service so that you can ingest data asynchronously. You can have pipelines running in the background. For .NET, there is still a way to run it without a service, but we really want to push into this idea that, like, as you run SQL Server or Cosmos DB as a service, the memory itself is a service. So one thing that we have done, we added API keys. So now you can deploy the service in the cloud without having to put in front a proxy, and you can specify a couple of API keys in the configuration. So that would allow you to protect the service. By default, they are empty, so it's up to you to set them up. Then there is a folder called clients where we currently have the .NET clients. So there is a web client, which is basically talking to the service and implements the AI memory interface. There it is, memory web client, implementing the kernel memory interface. And there is a plugin, which is what you can use with the kernel with the planners to talk to your memory. And I will show you a little bit of code later. Since we've done these changes, we also published a new set of packages. These are the new packages that we have. There is a new package, very important one, called abstractions, that contains all the interfaces and the classes. Is compatible with .NET Standard 2.0, so it should work pretty much everywhere. And you can use these abstractions to build extensions to the kernel memory. For example, so this has been coming up a lot, like, can I use Postgres? Can I use Elasticsearch? Can I use hybrid search? These abstractions is a fundamental piece for that. And then, for example, we created a repo to show how you would extend the kernel memory with Postgres. So if you look at this repo, it basically shows you you can create a new memory storage class. You only need to take dependency on the kernel memory abstractions, nothing else. So you can work with .NET 6.0 or even the framework maybe. And you just have to implement this interface iVectorDB, which is going to be, we are renaming the interface, but the approach is still the same. You can say, I want to work with Postgres, implement the interface. So there are a few methods to implement. All of these are empty right now, but they just give you an idea how easy it is to plug in your own storage. And then there are some helpers for dependency injection, so you can easily import Postgres. In this case, like you can say with Postgres, or if you're using the builder, or you can typically do service collection methods like add Postgres as vector.db. So very simple. The idea is that we're going to have several repos like this, one for each connector. If you look at the semantic kernel folders, you see we have a lot of memory connectors here, Chroma, DuckDB, Custo, etc. We would like the community to help here and not having everyone to work on the same repo. Like, you want to use Chroma, you want to use DuckDB, you want to use Weaviate, please create a repo and follow the same pattern. It should be very simple, and we can all work around one connector without having to worry about the rest, as long as we follow that interface. We can help standing them up, but typically you might want to stand it up on yourself. It doesn't need to be owned by Microsoft. I saw there was a question about Weaviate. Like, all the files have these copyright by Microsoft. It doesn't need to be like that. You know, it's just code. You can publish the NuGet package. For example, if you look here, there is a Llama Sharp kernel memory package. You can deploy your own, and we will help advertise your extension. We will call it out in the repo. Say, for example, in the memory repo, we say, here we have a list of supported backends. We can say, okay, we're going to add these other into the list if you deploy something new to NuGet. Other things, let me see. So for people who wanted to work in Elasticsearch, this is exactly our suggestion. So please create a repo for Elasticsearch, take dependency on that package, the extension, abstraction, sorry, and implement the interface, and we will help you advertise and make it work. Then, of course, there is going to be breaking changes over time. We're trying to stop doing that with the kernel, but also with the memory. There is one in particular breaking change coming this week that I will explain in a second. And talking about the plugin, if you want to see how that works, now in the repo there is a new notebook showing how you would use the kernel memory with the kernel. So using the latest beta, this is the latest version we had when we published the NuGet, the notebook. You set up the usual credentials, blah, blah, blah. So here, this is the kernel builder. So we prepared the kernel to work with Azure, with OpenAI. And then we set up the kernel memory. We say, I'm running my memory service on this endpoint locally. This is my memory, my API key, which is .m file. I stand up a client, which you could call connector in the old world, like the kernel. I'm going to give it a name. I want to call it memory. And then you do the usual kernel.import functions, an instance of the plugin, the plugin constructor takes a dependency on the connector, so this client. And you can also set up the plugin in a couple of ways. You can say, whenever I write, I want to wait for when I am uploading a document, I want to wait for that document to be completely memorized, or I don't. I don't want to wait, just send the write, and that's it. So it could be much faster, but it depends on your scenario. Then here, what we're doing, we're uploading some text, like this is a copy and paste from Wikipedia about Orion, which is a set of stars. And then I'm using the same connector or the plugin to upload a file, which is here. This is a news about Orion from August, I think. So we're uploading this file to the plugin, using the plugin. So the system automatically extracts the text, chunk it, put in memory, using embeddings and all that. And I'm calling the save file. Here you see I'm using the plugin. I could do the same using the connector. It's up to you which one, depending on your scenario. So here now I have two memories. One about Orion as a set of stars, and one about Orion as a spacecraft. Okay. So the old memory plugin would allow you to recall facts as a list of text, like list of strings coming from database. The new plugin has this ask method that you can use in your prompts. Like I'm providing a question, then I'm calling the plugin.ask method with that question. So these will be replaced with the answer coming from the service. And I'm doing some work here. Like if the answer is I don't know, like sometimes the memory will reply I don't know. Sorry, if the answer is empty, say I don't know. Otherwise, reply with a preview of the answer, truncated to 50 words, blah, 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 prefix with an emoji. So just to show you how you can compose the plugin with prompts in the usual way. And here, create a function, semantic function for this prompt. So now here, we run it. I think this was the old name of the function. I renamed because it was confusing. So, for example, any news from NASA about Orion, so the service will reply back with an answer like Orion, yeah, there is a conference call, blah, blah. And now our prompt is re-elaborating using this command. And it's also adding an emoji in front. You can see here, like NASA is inviting media, which is relevant because we're talking about spacecraft. And then I'm asking another question, what is Orion? Now here in memory, we have two definitions. Orion is a set of stars, and also the memory has inferred that Orion is a spacecraft from the news. So we get this answer, Orion is a constellation and also a NASA spacecraft. So these are everything coming together here, as you can see. Simple example. And now you should be able to store your data and from JSON, from PDF, from documents, from presentations, and being able to use these ask questions and do whatever you want, like injecting into your chat. Other things, more technical, we have upgraded the dependencies in the kernel. So we're using the latest kernel, Semantic Kernel Beta 8. And we also upgraded text to the community to the latest search to the stable version 11.5, which is using the latest vector search settings and syntax for vector search. And we also upgraded poly, RabbitMQ, and other things. We have replaced our custom cosine similarity implementation with the one coming from the .NET team in system numeric extensor. This is now this cosine similarity method. We're using that. We're not using ours anymore, which was an unsafe method. And other things, the prompts can be customizable. I don't know if I already gave this news last time. When you stand up the service, there is a set of custom prompts which are used for the rack pattern. Now those prompts can be customized. I think prompts here they are. So now these prompt, which is the one used to generate an answer, can be customized if you like. One important thing in progress. So there is this, if you've used Azure AI Search, you might have seen this new feature, relatively new, called semantic ranking. You can basically write text, don't worry about embeddings, and they do everything for you. So in order to get there, we have this change, which is in progress. We are renaming the iVectorDB interface to iMemoryDB. And when we search, so when you implement your memory connector like Postgres, Elasticsearch, or Azure AI Search, now your search method will not doesn't require an input and embedding, but will receive the user text. Now it's up to you to decide what to do with the text. You might want to calculate the embedding locally in your class, or you might want to pass the text to your database, like Azure AI Search, and let it do all the work internally. This works also with ChromaDB. If you know, you can optionally configure ChromaDB to automatically do the embedding internally for you, which is nice. You don't have to worry about the complexity. So this change makes it more flexible so that we can later on implement hybrid search, which is another feature that has been asked for a lot of time, like the ability to combine vector search and semantic search and text search. And I think we've done everything. Any questions?
So the biggest question that I see in the chat is mostly about, sounds like there's desire and eagerness to create these connectors from the community, but there's a question on exactly like how to do so, because as you can see, right, it's like, okay, maybe having different repos adds more complexity, and especially if you have licensing concerns, right, it could introduce a complex situation. So
yeah, I understand. Yeah, the thing is that I think the idea that Microsoft can create a connector for every database in the world doesn't scale. So it's preferable having individual repos where we focus on an individual database, like Elasticsearch or I don't know, MongoDB or anything. I mean, there will be more and more in the future, or even services like Fabric. You might want to use Fabric as a database where you put data, you read out. And then who drives that? I think it's best if the community takes care of it, because we are currently very active on this. We might not have the same resources a year from now, and we don't want to abandon the project or suddenly disappear, and the community will think, oh, what do we do about that now? So I think we're available now to help bootstrapping that process. We can help you setting up a repo. If it is owned by Microsoft, we won't be able to transfer the ownership. So I think it's better if the repo is created by the individual companies like Weaviate and Pinecone and etc. And then we can help. We can be the main contributors just for the start, and then we let it go and say, okay, now you see the interface, and you can add as many options as you like. And there also can be multiple connectors for the same storage. Like you don't need to have only one for Python or only one for Weaviate. You might have a different idea. Say, I want to use Weaviate differently, or my company does something special with Azure AI Search. And rather than waiting for Microsoft to create a connector with all the options, I'm going to go and do my own. We provide the interface if the interface is useful. Otherwise, please give us feedback. We can make it easier. We can add new methods, or we can revisit the existing ones so that everything comes together. I think ideally, from a user perspective, from a developer perspective, I just want to use the plugin, and I want to choose a connector without having to worry too much about the implementation details. So we try to make it easy. We have the plugin now. The plugin will be available also for other languages like Python and Java and Node.js. Writing a plugin is easy because you just have to write a web client. And we try to create a community around the storage part. Like everyone comes up with a new storage, we can help them creating a connector.
awesome. Alessandro, I see your hand up.
Yeah, a quick question, Devis, that came from your demo earlier. Can we swap the embedding generator? I'd like to use a 384 dimension model in Kernel.
Yes.
We can do that too.
Absolutely, yes. Yeah. You can
And-
swap it, and to some degree, you can also use more than one embedding generators. I haven't tried yet, but if somebody wants to try having multiple embeddings, it is possible. Like the design allows it. I've never tried. There might be some bugs, but you could say I want to store in my records a very lightweight embedding, and then a more heavy, expensive embedding. And now I have two embeddings. I have logic to fall back from one to the other, or I might want to compare the quality, or you might have scenarios where one is good enough because it's fast, the other one is more expensive. You use it only in a specific scenario. So I think we try to allow, the one idea behind the kernel memory was to enable experimentation. Like if you have some crazy idea, like you want to use multiple models, custom models, local models, or you don't want to use any embeddings, just full text search, we want to allow that. So the interface should be designed to enable you. Also, the way that we compose dependencies should allow to do that.
Great. In the interest of time, well, I'll just quickly go over to my screen. Alessandro actually submitted many questions, but I think if I heard Devis correctly, I think he actually answered quite a few of them. But
that is true. Yeah.
yeah, but so I'll highlight a couple of questions I think are important to at least call out. So this one came from John, which basically says that, hey, if you saw Ignite, right, there's a partnership that was announced with LangChain and Microsoft. So what does that mean with Semantic Kernel Python support? Like, as mentioned in the very beginning, we are still investing in it. And as also mentioned, right, we have Evan Matson, who just joined full time to work on Python. So yes, we are still investing in it. The broader Microsoft stance is that these things can coexist. A developer will choose whatever he or she thinks is the best, thing for them. But we give you the choice. So yeah, some of these other questions maybe we can dig in later. The other questions, yeah, many questions around kernel memory, but I think again Devis answered it all. Okay, this is a good one to call out. So Carl asks effectively about like SK and prompt flow. So if you go to my YouTube or just search up semantic kernel and prompt flow, you can see actually a few different demos of how these two frameworks can work with one another. They're actually like quite compatible. You can use prompt flow if you want to evaluate a lot of your kernel plugins or skills or whatever things that you're writing. It is true that today it is Python first, or prompt flow at least. But I know for a fact that they are working on C# and maybe some other interfaces as well. But anyway, so prompt flow again is very compatible with SK. So this is a good one, but probably is best to cover in a future conversation, future call. It was basically about like the cost efficiency of SK. So actually our team has been kind of doing this type of analysis themselves. So yes, we can come back to this. I think it's a very interesting and good question. It's like, okay, if you're going to be using SK, if you're going to be using examples like Chat Copilot, like how much does it actually cost to run? So again, more about memory and the rest are great questions from Alessandro. But cool. All right, we are at time. Thank you, everybody. Yeah, thanks Alessandro for these questions. They're good. But yes, thank you everybody for coming to Office Hours today. And yes, sign up for the hackathon. And yeah, look forward to seeing what you guys all build. All right. Take care.
Bye, everyone.
Thanks, everyone.